Hello, and welcome to CRPS Contender, my complex regional pain syndrome education channel. Today's video is Noshing for Neural Health, Part 1, Tyrosine and Tryptophan. Before we get into the meaty content of this video, I want to do a quick refresher on what CRPS is, in case for some reason you're unfamiliar, which is fair. CRPS is the result of a painfully dysregulated autonomic nervous system. It's a degenerative immunoneurological condition of a dysfunctional autonomic nervous system, including your sympathetic, parasympathetic, enteric, and limbic subsections of the nervous system. So what do each of those areas do in a broad sort of sense? The sympathetic system is responsible for your mobilization responses. This is your fight, flight, freeze, and fawn responses. It takes control of your defensive behaviors. Your parasympathetic system basically works in the opposite direction of your sympathetic system. It is responsible for your maintenance responses: feed, fatigue, getting laid, and fun. It is responsible for social engagement behavior. The third system is your enteric system, and this is responsible for the motility responses of your intestinal tract. It takes charge of things like peristalsis, which is the reflexive contraction of your intestinal muscles to move food through your system, secretion, and absorption of nutrition. It is responsible for your digestive behavior. And then finally, your limbic system. This is in your brain. This is responsible for motivation and memory responses. And what I mean by motivation, I'm including emotion here, because that is what emotion is. It is a central motivational state to promote doing something. It also is responsible for regulating your autonomic and endocrine systems. It is responsible for self-preservation. Your neural structures communicate with each other to carry out their functions using a wide variety of chemical messengers. These messengers are called neurotransmitters. Each type of neurotransmitter fulfills a particular type of function, and it does one of two things mainly. It either excites the neuron, encouraging it to fire, which is known as an action potential, or it inhibits the neuron, discouraging it from firing and creating an action potential. Okay, so you need to know those terms. Neurotransmitters are usually either excitatory or inhibitory. There is another one called modulatory, but we're not going to focus on that right now. Neurotransmitters are created out of nutrients called amino acids, which are the building blocks of proteins. And enzymes carry out the chemical conversions of these amino acids into neurotransmitters that your nervous system can utilize. The amount of a particular neurotransmitter that is created is dependent on the presence and the amount of its precursor amino acid. Now, a precursor means what it was before it was this other thing. So before it is this neurotransmitter, it was this amino acid. Okay, that's what a precursor is. And that is what we're going to be focusing on today. But before we do that, I want to talk about some of the major neurotransmitters and their function. Right now, we know there are more than 100 neurotransmitters, and there's probably a lot more than that. There might be more than 500. So we don't need to know all of those. We're not going to focus on all of those. We are only going to focus on 8 of them. These few do the majority of the work. Acetylcholine is an excitatory neurotransmitter. It stimulates muscle contractions, mainly in your somatic nervous system, and it regulates attention, learning, memory, and your sleep cycle. Histamine is also excitatory. Now, this works primarily in inflammatory responses, but it's also responsible for things like vasodilation, blood pressure, perception of pain, arousal, not sexual arousal, but just like cognitive arousal, and your stomach acidity. Glutamate is the primary excitatory neurotransmitter in your central nervous system. We are going to have another video talking about glutamate specifically. Glutamate is responsible for synaptic plasticity, which is the way that your brain connects to itself and its capacity to heal itself. In high levels, glutamate is toxic to your nervous system. The glutamate neurotransmitter binds to receptors on your neurons known as NMDA receptors and AMPA receptors. And specifically, if you get ketamine, it is binding to this NMDA receptor here to prevent glutamate from causing a neuron to fire. GABA is the primary inhibitory neurotransmitter in the central nervous system. It is responsible for inhibiting informational noise as it travels from one neuron to the next, and from blocking entire signaling pathways. It promotes sleep, and deficits in GABA can cause anxiety. This is synthesized, which means it's created, from glutamate and the vitamin B6. Serotonin, which is one of the ones we are going to be talking about today, is dependent on the precursor tryptophan. Serotonin regulates the activity of your cognitive, emotional, physiological, and metabolic systems, including things like mood, sleep, wakefulness, appetite, aggression, your circadian rhythm, body temperature, and your neuroendocrine function. The next three all come from the same precursor, tyrosine, which we are also going to be discussing today. Dopamine is unique because it functions in both an inhibitory and an excitatory sense depending on where in the nervous system it is being utilized. It regulates reward learning and prediction. This is a very motivating neurotransmitter, and it is in charge of your want system. When this system gets out of hand, this is what leads to addictive behavior. Noradrenaline is the primary neurotransmitter of your sympathetic nervous system. This neurotransmitter is responsible for mobilizing us for action, and it responds to stress. It is mainly responsible for arousal. Again, this is not sexual arousal, but rather a cognitive sort of arousal. Attention, focus, and concentration. And then adrenaline. Adrenaline is excitatory. It is also a bit unique because it is a hormone as well as a neurotransmitter. This is what happens when your sympathetic nervous system gets activated and you have a fight or flight strike. It is a highly, highly stimulating neurotransmitter, and it increases heart rate, blood pressure, and the release of glucose to make sure you have the energy to do what is necessary to protect yourself from a threat. So now let's talk about tyrosine. Now this is the catecholamine precursor. Catecholamines are dopamine, noradrenaline, and adrenaline. You might also hear noradrenaline and adrenaline called norepinephrine or epinephrine. They're the exact same thing. They just have different names. Tyrosine is also the precursor to your thyroid hormones and melanin. Tyrosine is a non-essential amino acid. It can be made from the essential amino acid phenylalanine. And I really hope I pronounced that correctly. If I didn't, that's what you get for reading and not going to medical school. Just a reminder, I'm not a doctor. Ingestion of tyrosine induces, within a 45-minute time frame, a significant but short-lasting blood plasma increase in noradrenaline, adrenaline, and dopamine, as well as a decrease in the dopamine metabolite, DOPAC. This means that instead of dopamine getting broken down basically into nothing and reused as something else, this means it's being converted to adrenaline instead. So that means more adrenaline in your system, leading to further CRPS flares. This short but significant increase has acute effects both inside and outside of the brain. The ingestion of tyrosine has the most effect during neurotransmitter depletion due to stress, which can be a physical type of stress like hypothermia or a loud noise, or a mental, psychological type of stress due to some sort of cognitively challenging task or another sort of mental activity. Now, for tyrosine to actually make it into the brain to be able to be used and turned into catecholamine neurotransmitters, it has to cross the blood-brain barrier. And there is limited transportation across this. It can't just enter your brain. It has to be brought in. And the amount of tyrosine that can enter depends on the ratio of tyrosine to other large neutral amino acids because they use the same transport system. This means the amount of catecholamines in your system is going to be reflective of what you're eating on a regular basis. Now, the WHO has a recommended daily intake for a standard adult at about 25 milligrams per kilogram a day. And this is of tyrosine and phenylalanine combined. Now, this next one, I'm not going to spend a lot of time on it. If you want to freeze the video frame to look at it, that's totally fine. This is the chemical conversion of phenylalanine and tyrosine into catecholamines. And this is just showing you how that happens in a visual sense. Okay, I'm moving on, but feel free to freeze this frame and look at it further if you want. All right, now we're going to talk about tryptophan, which is serotonin's precursor. Tryptophan has significant sedative-like properties, but it does not appear to impair performance. It is an essential amino acid, which means your body cannot produce it on its own. It is used to synthesize serotonin, niacin, which is vitamin B6, melatonin, and kynurenine. Serotonin increases sleep quality, emotional well-being, and pain tolerance. It reduces depression and anxiety, and regulates aggression and pro-social behavior. Now, oxytocin is responsible for the formation of social bonds. However, it is serotonin that sets the tone of the interactions after those bonds have been formed. It regulates the tone of interactions along an agonistic, affiliative, or agreeable to quarrelsome axis. Again, tryptophan competes for blood-brain barrier transport to be able to enter the brain. This happens in the same way of tyrosine, where all the large neutral amino acids are competing for access to the transport vessels. Now, carbohydrates remove all the amino acids except for tryptophan from the blood, eliminating competition and boosting serotonin levels in the central nervous system. Now, the WHO has a recommended daily intake of tryptophan for your standard adult at 4 milligrams per kilogram per day. Now, this is only about 16% of the regular daily intake of tyrosine and phenylalanine. And again, here is that chemical equation for you so that you can see how tryptophan becomes serotonin. Carbohydrate-rich foods cause considerably greater serotonin amplification than catecholamine release. Protein-rich foods reduce catecholamine output less than they reduce serotonin output. And that's a bit of a word salad there. Can be a bit hard to understand, but basically what that comes down to is that more carbohydrates means that your serotonin levels are going to be increased, whereas more proteins, particularly red meat proteins, are going to have a higher catecholamine increase. The carbohydrate-protein ratio that will neither raise nor lower blood plasma large neutral amino acids is about 5 to 6 to 1. So what does this look like when it is not balanced at 5 to 6 to 1, but instead has a higher carbohydrate ratio? A carbohydrate-rich meal affects your tryptophan LNAA ratio, increasing tryptophan by 11%, which peaks 120 minutes after ingestion of the carbohydrates. A protein-rich meal, on the other hand, affects the tryptophan LNAA ratio by decreasing tryptophan 37%, which peaks 240 minutes, about 4 hours, after ingestion. Over the course of those 4 hours, the median difference of tryptophan levels between a carbohydrate-rich meal and a protein-rich meal is a whopping 54%, ranging from 36 to 88%. This means that typical meals can cause significant variations in your tryptophan and tyrosine ratios compared to other LNAAs, depending on the proportions of carbs and protein ingested. Differences can be greater than 50% for tryptophan and are about 30% for tyrosine. These variations are sufficient to produce major changes in brain neurotransmitter concentrations. The capacity of meals or snacks to increase or decrease brain serotonin is considerable. These effects are buffered at meals, where several food groups are consumed. However, single food snacks have largely unbuffered effects. The magnitude of plasma LNAA alterations after a carbohydrate-rich food is consumed likely depends on your recent nutritional history. Neurotransmitters are made in relation to the available materials of tyrosine and tryptophan. Changing dietary habits is not an immediate quick fix. It is a dedicated choice over time for healthier physiology. The goal here is not to remove all tyrosine from your diet. It is instead to increase the tryptophan ratio of tyrosine and other large neutral amino acids. As you saw earlier, the daily recommended intake for tryptophan is only about 16% of what is recommended for tyrosine. Tyrosine is important. You need to be able to have catecholamines to function. We are not trying to remove that entirely. That is not the goal. The goal is to reduce catecholamine output and the CRPS flares that follow a sympathetic nervous system strike, and to increase the antidepressive, mood-improving, pro-social effects of serotonin by altering the precursor levels of tyrosine and tryptophan. Now, if you're not quite sure exactly what to do with that, you can check out my source links for this. I've got a whole page of sources down in the description below, where I also have several links to like foods that are heavy in tyrosine or tryptophan if you want to check that out. But the one diet I would like to at least bring to your attention here is Hooshmand's 4F diet. Now, Dr. Hooshmand was a CRPS expert who worked with our community and researched our community for many decades. And this is the diet that he has created specifically for CRPS patients. So I want to talk about it. Now, this is called the 4F diet, which stands for fresh, veg, fruit, fish, and fowl. And I want to talk about what to avoid first, and then we'll talk about what's okay. So, things to avoid. Crystalline sugar, sugary soft drinks, pies, cakes, sweet rolls, and donuts, organ meats, bacon, red meats and sharp cheeses, sherbet, ice cream, non-dairy creamers, bleached flour, white bread, chips and dip, Crisco, mayo, butter, margarine, lard, and other types of saturated fats, candy, fried foods, syrupy fruit, which specifically means like canned fruit that's in like light syrup or heavy syrup, and then actual syrup, coffee, and all kinds of alcohol, whether that's cocktails, beer, spirits, wine, whatever. All alcohol should be avoided if you have CRPS. Things that are okay. Unsweetened orange juice and unsweetened apple juice and other natural fresh juices with no added sugars. All fresh fruits, all fresh vegetables, and dried fruits. Mild white cheese, cottage cheese, plain yogurt. That's something like you can add your own fruit to, or if you want to toss a little bit of honey in there. This is talking about yogurt that has added sugars in it. Skim milk, eggs of about 2 eggs a week, and olive oil. Oatmeal, whole grain cereals, and honey. All fish, water-packed tuna, shrimp, crab, and lobster. Chicken, or other skinned fowl, and unsalted nuts. And caffeine-free, sugar-free, low to no sodium diet drinks. Things that could be consumed in moderation, but you'll want to be kind of careful with them. Lean roast beef, veal, lamb, and tea. There is one other thing I'd like to bring to your attention. I was a little hesitant to add this, but I am going to. St. John's wort. This is a wild-grown, yellow-flowering plant that has been utilized for mental health for centuries. The mechanisms for this plant are not fully understood, but it does appear to increase specifically the serotonin, but also dopamine and noradrenaline levels. It may work similar to an SSRI by preventing the reabsorption of serotonin after it has released from a neuron into the neuronal synapse where communications are sent from one neuron to the other. Evidence from scientific studies for this is mixed, but it does appear to be more effective than a placebo and as effective as standard antidepressants for mild to moderate depression, and it has fewer side effects. Now, if you are dealing and struggling with severe depression, this is definitely something you're going to want to have handled by a professional. You're going to probably want to get on prescribed antidepressants. I am not telling you not to go to the doctor if you have access to one. But if you can't go to the doctor, if you don't have insurance, if you can't get the help that you need, and you're struggling with depression, you are having an unbalanced, unstable mood, you can't sleep, and you don't want to interact with anybody, the world is just gray and washed out before you, St. John's wort is an over-the-counter medication. It's a supplement. It would be in the supplement aisle. That only costs a couple bucks for a big bottle of it. I personally utilize this, and it really, really helps me. So if for some reason you can't get on prescription antidepressants and you want to try this, I at least want to throw it out there for you. However, do not, under any circumstances, mix St. John's worts with certain antidepressants, such as SSRIs and MAOs. This can cause an unhealthy serotonin increase, leading to serotonin syndrome. This is very dangerous and can be life-threatening. St. John's wort also weakens the effectiveness of several drugs, including things like birth control, heart medications, HIV drugs, transplant medications, oxycodone, cancer drugs, blood thinners, and anxiety medications. Now, the list I have here covers some of the major ones, but this list is actually quite long. So if you are taking prescription medications, you need to check that list before you start taking St. John's wort if you decide you want to do that. You should also make sure you are telling your doctor about supplements that you are taking so that they can be aware of how that might interact with medications that they would prescribe. A normal dose is quite variable, ranging from 300 to 1200 milligrams a day in divided doses, meaning 2 or 3 times throughout the day. If you're in the US, this is not FDA approved, which means it is not regulated. However, in Germany, this is not the case, and it is utilized much more frequently for depression. So, in Germany, the depressant dosage that is usually prescribed is 300 milligrams 3 times a day, with an extract of 0.12 to 0.3% of hypericin, which is a chemical inside St. John's wort, which is what they think is actually doing the work. Yes, okay, I think I've talked on this long enough. My point is, if you want some extra help to boost your serotonin, St. John's wort might be able to assist you, but please make sure that you are taking the necessary due diligence and precautions to not further harm yourself by taking a supplement. Just make sure you know what you're doing. Okay, so what have we covered today? Covering a little bit of what CRPS is, an immunoneurological dysfunction, talking about some of the major neurotransmitters and their functions, talking about tyrosine, the precursor to catecholamines, and tryptophan, the precursor to serotonin. The ratio of carbohydrates to protein and how that impacts the way tyrosine and tryptophan get to the brain, and the ratio of tryptophan to tyrosine and how that impacts which neurotransmitters get created and then utilized. We also discussed Hooshmand's 4F dietary habits, which focus on fish, fowl, fruits, and fresh vegetables, and we discussed using St. John's wort to help boost serotonin if you need some extra help. Noshing for neural health is going to be in many parts. Today we covered tyrosine and tryptophan, but I will also be discussing glutamate, polyunsaturated fatty acids, and saccharides. I might even go further. Who knows? Right now, I'm thinking 4 parts, but we'll see. Okay, thanks so much for watching. If you want to help my channel out, like, share, or subscribe. If you would like to contribute to my medical expenses, my Patreon is listed below. Thank you so much to Chase for being my first patron. And of course, as always, relevant sources are linked in the description below. I hope you learned something today, and I hope to see you next time.